In this video, I want to talk more about inverse functions and how to find them. So in the last video, we talked about how a function takes the domain and puts out the range, but the inverse function is the undoing function. It's the function that takes those range values in as its domain, and it undoes them, and you get back as the output the original function. So it's basically the undoing function for x. So in each case, I want to find f inverse of x. So in this pink example, f of x is just a list of 3 points. So in this case, we know that the outputs become the inputs and the inputs become the outputs. So for f inverse of x, if all of the outputs turn into the inputs and the inputs turn into the outputs, all we need to do is, the input is the x value, right, and the output is the y value, so basically we just need to switch those. We need to put the input for the output and the output for the input. So 0, 1 becomes 1, 0, and that's the undoing function. 1, 3 becomes 3, 1. And 2, 9 becomes 9, 2. And that's the undoing function for f inverse for f of x. So if somebody asked you what was f inverse of 1, you would say, okay, well, the output, when I input 1, it's backwards of the function, right? So the inverse takes in the outputs and gives you back the inputs. So here it would be 1, f inverse of 1 is 0. Okay, so those are fairly easy, but most functions don't come in that format. So let's look at a format we're more familiar with, whereas when you're given an equation. So when we have an inverse function, we're basically switching the output and the input. The output becomes the input becomes the output. So what we need to do is write down y equals, let me do this in green, y equals x plus 2 over 3x minus 4. And then what we want to do is we want to switch the x and the y. So because that's basically what we're doing. Again, we're changing the domain and the range, switch places. So we're going to write x equals y plus 2 over 3y minus 4. Okay, now what? Well, now what is we need to get y by itself. So the first thing I want to do is get this y out of the denominator. So I'm going to multiply both sides by 3y minus 4. And some of these take quite a bit of algebra, but it's not too difficult usually. So that goes away. So we have y plus 2 equals 3xy minus 4x. Okay, now to get y by itself, we need to get all the y stuff on one side and the x stuff on the other side. So I'm going to move this y over, and I'm going to move the 4x over. So this goes away and this goes away, and we have 3xy minus y equals 4x plus 2. Okay, now on this side I want to factor out the y, so I get 3x minus 1 equals 4x plus 2. And then to get y finally by itself, I'm going to divide both sides by 3x minus 1. And then I have y equals 4x plus 2 over 3x minus 1. And that should be the inverse function of f of x. Now, again, we can check that and be sure by doing, so this white one is, let's just be clear, this is f inverse of x. So we can check by doing f of f inverse and f inverse of f by composing those two functions. So we can do f inverse of f of x to check. So this would be 4 times x plus 2 over 3x minus 4 plus 2 over 3 times f, which is x plus 2 over 3x minus 4 minus 1. Okay, and let's see what that works out to be. So we can multiply these numbers right into the numerator. So this would be 4x plus 8 over 3x minus 4 plus 2, which is 2 times 3x. We need to have a common denominator here. So we're going to get 3x minus 4 as our common denominator. So 2 times 3x minus 4 over 3x minus 4 all over 3x plus 6 over 3x minus 4 minus 1 times 3x plus minus 4 over 3x minus 4. Okay, now that we have a common denominator, we can actually multiply the top and the bottom here by 3x minus 4 over 3x minus 4. So that's multiplying by 1. And so that's going to cancel that out and just cancel all those denominators out. So now we have 4x plus 6x. So that would be 10x minus 4 on top, or plus 4, sorry. And then on the bottom, we have, let's see, just 10. This should be 3x. Oh, this needs to be distributed. Okay, never mind. On the top, we have, sorry about that, just a little mistake. On the top, we have 10x because we've got 4x here, and then we've got 6x here. And here we have minus 8, right? This is actually 6x minus 8. So we have plus 8 minus 8, so that's 0. Okay, so we just have 10x. And then on the bottom, we have 3x minus 3x. And then we have 6 minus negative 4. So 6 plus 4, which is 10. So that is just equal to x, which is what we wanted. Okay, and you don't need to do all that work. I just wanted to show you how it would work out just like we did in the previous video, where f inverse of f of x is equal to x. And that should always work, and you can do that to check your work, but you don't always have to. Okay, so that was a long way to check, and I don't want you to get bogged down in checking, but that is how you do check. And I'm going to go ahead and erase this checking stuff because it's kind of in my way. So you can check in that way, but like I said, you don't need to get bogged down by that. That's extra, but this is to check. So, so we do this to check. Okay, so let's do the third and final equation. So the third equation is f of x equals 2x to the third minus 7. So if we rewrite that in y equals format, that's y equals 2x to the third minus 7. So then if we want to solve for the inverse function, we switch x and y. So x equals 2y to the third minus 7. And then we solve for y. So the first thing I would do is add 7 to both sides. And I would get 2y to the third over here equals x plus 7 over here. Divide both sides by 2. And then I'm getting y to the third equals x plus 7 over 2. And then I would take the third root of both sides. That's the opposite of the third power, is the third root. So y would equal the third root of x plus 7 over 2. Okay. So now let's talk a little bit about those domains and ranges. So you can't get away from domains and ranges. And in this case, going back to our very first example, our domain of f is 0, 1, and 2. And our range is 1, 3, and 9. So for the inverse function, it's the opposite, right? The domain of the inverse function is going to be the domain of that inverse function. Sorry, I just erased something I didn't mean to erase. The domain of the inverse function is going to be just 1, 3, and 9. And the range of that inverse function is going to be 0, 1, and 2. Okay. So that's fairly simple, and that's the opposite of what it would be for f of x. Now, in our second example, this green example, the domain of the function itself is everything except x equals 4/3, right? Because where this equals 0. So the domain is everything except that. But for the function, for the inverse function, so the inverse function is this, and the domain, so in this one, the domain can't have, x cannot equal 1/3, right? So you do need to be careful and check if we have x's in the denominator. That's going to be something that's disallowed in the domain. But remember that the range, sorry, there should be a not equal to. So in here, the domain can't be equal to 1/3. You'll notice that the range, this would be a rational function, right? And it would have a horizontal asymptote at 4/3, which means that there's no output values at 4/3. So the range is going to be y can't equal 4/3. Well, if you go back up here, you'll notice that that was the same restriction that you have in your domain. So the domain of the original function, if we can't let the bottom equal 0, which means that x cannot equal 4/3. So the domain here is that x cannot equal 4/3. And again, you'll notice that the range here, this is a function with a horizontal asymptote, and that horizontal asymptote, because the degree is the same, it would be 1/3. So the range wouldn't include that 1/3 value. So y cannot equal 1/3, which is the same as the domain of the inverse function. So the range of the original function has the same problem that the domain of the inverse function has, and vice versa. The range of the other function, of the inverse function, has the same problem that the domain has in the regular function. So the domains and ranges stay the same, but they switch. But the same problems exist for both. But you don't really need to know all of that just to do the problem. You just need to look for problems in the domain. I just want you to be aware of it. In this function, the domain here is all real numbers, and the range should also be all real numbers.